Now we will focus on the particular characteristics of controls and layouts in relation to the use of web panels that we've already seen, mainly the aspects that are indicated here, starting with the first one. Two areas constitute a layout. The area known as application bar, where buttons can be placed. They may or may not have associated images. They will correspond to actions to be run over the data or calls to the screens, and so on. Or containers of groups of actions, group control, to group several actions and offer them as drop-down menus, for example. The second area is the layout itself, which offers a toolbox to insert the controls. In the detail node, placeholders for the various sections will also be displayed in addition to those we have here. Now we will focus on this second area and leave the first one for later. Here is the list of the work with speakers. Speaker image and speaker name are displayed by default. Now we will add an attribute, the speaker's country. For the controls of attributes or variables, the label position property will allow us to specify the position of the tag of the attribute or variable that is an attribute. Each platform has a default value. In Android, for example, it is top. This means that the tag will be displayed above the attribute control. Here it is on the left, because this is a generic screen and not an Android screen. If we select the value none, the tag will not be displayed. Let's see it in GeneXus. We open Work with Speaker and select the list. Here are the two controls we have for now. In the layout grid, we open the toolbox and insert a new attribute by dragging it. We select it, country name, and see that first, a new row and column have been added to the grid table. In addition, if we open the properties, we see that the level position property is set to platform default. If we run it, we see that for Android, this default value is on top. We change it to none to hide the tag. We save and run to see the change applied. We run the dashboard object. And we open the emulator that was left open in the last execution. In fact, if we hurry before the new PK is loaded, we see that only the speaker's photo and name were displayed. Now, in the new one, the country will also be displayed. Note how long the compilation is taking. The reason is that we're adding a new control as well as a new attribute, and to do so, it will have to access the database to retrieve the information. That's why in this case, we can't avoid running all these compilation steps and uploading the app to the cloud. However, soon we will see when we can skip these steps. If we select speakers, now we see the country. We return to the PowerPoint slides. Working with tables will be fundamental in smart device applications. Every layout, even when it's empty, will have a root table called main table. We can see it here when we're positioned on the grid table. Here is the control we're positioned in with all its hierarchies, the parent, and where this parent is inserted. Every control is inserted in the main table. In turn, every grid will define a table. This table here will contain the controls of each line to be loaded, of each element in that grid that will be loaded from the database. In this case, the table has 2 columns and 2 rows. Look at the 2 properties, column style and row style, which will allow us to define the size of each column and row of the table. Note that the column size can be defined or specified in two units: percentages or DIPs, device independent pixels. This unit corresponds to the abstraction of 1 pixel, which later an application converts into physical pixels in order to scale to different screen sizes using standardized sizes, DIPs. The DIP value has a different number of pixels for each platform. Percentages are relative to the value resulting from subtracting the fixed values from the total width in DIPs. So, if the total width is 384 DIPs, the screen width, and there is a column of 64 DIPs, as we can see here, the 100% that will be taken by the remaining column will result from subtracting this total width, this number of DIPs. The size of this column will then be 320 DIPs. If we had 3 columns, as we can see here, the first one with 30%, the second one with a fixed value of 10 DIPs, and the third one with 70%, the values taken by the first and the third one, expressed in percentages, will be obtained by applying these percentages to the value resulting from subtracting the sum of the fixed values, only one here, 10 DIPs, from the total that in this case is 384. That is to say, 384 minus 10 equals 374. So, the number of DIPs taken by the first column will be 30% of that value, and the last one will be 70% of that value. So now we will do this. We will add a column. Our table had 2 columns, and we will add a third one of 10 DIPs to insert a blank space, as we can see here, between the first and third column so as not to show the values so close together as they were in the application. So we return to GeneXus. We select Work with Speakers and click Anywhere. We select Insert Column After and see that now we have 3 columns. We click on the table, and after changing its properties, the column sizes are as follows: the first one of 64 DIPs, the second of the remaining 50%, and the third one of the remaining 50%. We change these values so that the first one takes 30%. The second one, a fixed size of 10 DIPs, and the third one, the remaining 70%. So, how can we test it? In the past, we would right-click on the dashboard again, and then select Run, unless we had a startup option, because in that case, we could just press F5. We view it in edit mode, and now we see a change that doesn't require compiling the application. It can be seen right away without having to wait for the compilation. So here is the application, and we select Speakers. There's a blank space between the details, and everything looks good. In addition, if we look at the rows, we see that the PD unit platform default has been added. It wasn't included in the previous case. This platform default value varies with the platform, precisely because it's a default value for each platform. And for the same platform, it also depends on the cell contents, on whether the field has a label or not. And if it has one, it'll be displayed on top or to the left. Also, all of this will vary depending on whether the layout is in edit mode or view mode. The platform default value can be defined as using the best value depending on the platform and the context. For example, for Android, with label position equals top, it corresponds to 64 DIPs, and in iOS, 53. Now is the time to reduce the time it takes to test the changes made to the app's design. And to this end, we will use the live editing tool. So far, Every time we wanted to test the changes made to the sizes of rows or columns in the tables, we had to specify and generate the application and compile all over again, which took considerable time. That's why we will introduce this tool that will allow us to make design changes and other behavior changes and instantly see the results without even saving. In this way, we can undo the changes immediately without any waiting time involved. Let's see it with an example. How? First, take a look at the speaker name attribute we had in the Work With Speakers grid. This speaker name attribute had the attribute title class associated with it, and that's why this attribute value was bigger than the rest. The speaker's name was bigger. In the emulator, we can see this size difference. In speaker, we see the property associated with the attribute title class. And it has this size and is causing it to be bigger. We will change this attribute. We will delete this one that had the attribute title class associated with it, and we will add the speaker full name attribute to replace it. We remove its level and set it to none. Look at how we're inserting a new attribute, and note that the pattern is the one that had associated the attribute title class with the previous attribute. It now has the attribute class with a standard value that will be the same as the country name attribute. So first, we will change its class. For example, suppose that instead of adding it as a title, we may want to change it to also have the shape it had before. But not only that, because we also want it to be displayed with the brand's color. That is to say, with the reddish color of the brand. To do so, we will save this attribute and then specify and generate it because an attribute has been changed. In this case, I must compile again because it will have to access the database to retrieve this new information. During this run, I will look at the Android theme. Note that I've already added the attribute title brand class to save time. It will have the brand color as 4-color. In addition, note that here I've also added the attribute tracks class, and that I've set colors for the various subclasses. I did the same at the table level, and we can see that I've added this table track class. We open and expand it to see these subclasses, such as blue to be displayed as background color when it's selected, or to be displayed in white and blue, and so on. We will talk about this later on to give this attractive design to the Android application that changes colors according to the session selected, the tracks, and so on. So, this is what we've been saying about the brand color, which should be displayed now. In this case, we select speakers and see that it has been loaded in the emulator. Here we see the full name in the same size as the country name. Perfect. So what did we say we wanted to do? Change this attribute's class so that it adds the new class I will enter. However, to do this, we would change the class and run the dashboard again, but I don't want this. I want to make the change and have it automatically applied in the emulator. I want to see the change without doing anything else, not even saving. In this case, we will use the live editing tool. How do we access this tool? By switching from the Release tab, the release value of this combo, to Live Editing. When we do this, this tab down here is displayed. For now, it doesn't have anything. So when I switch, I have to compile the application so that Live Editing starts listening to this compiled application in the device and connects to it. In this way, it can connect and listen to what is displayed in the device. While we wait for the compilation to end, Live Editing is a GeneXus tool that allows us to make changes to themes, languages, layouts, and user events in our panels and see the changes instantly in the application at runtime without the need to specify, generate, and compile. We don't even have to save the changes. I've said this several times already, but I'm saying it again because it's very important. In this way, the live editing server will be listening to the changes we make in the application and will replicate these changes over the metadata accessed by the mobile device. In this case, it's the emulator, but it could be an actual device. This metadata is used to draw the screen in the device and define its behavior. So, by changing the metadata, we will be able to instantly apply the changes without compiling anything. Now let's see if it has started. We see that the application is now displayed in our emulator. And this entry here says that it's listening to this emulator, or rather, the application in this emulator, with the simple Android theme, in English language and Android operating system. What do I want to do? I want to enable the Live Inspector. Doing so opens another tab here that apparently doesn't show anything because the dashboard element cannot be inspected or changed. Its changes can't be shown on the screen, but it can be done in the emulator. So we select Speakers. For example, it's automatically reflected in this other screen here. If we tap on the speaker Alejandro Simas, we see that it's automatically loaded in the Live Inspector screen. The information we're viewing in the device is automatically loaded. I go back and see that it's shown again. It's interesting to note that we can also work directly on the screen and change design aspects here and see them automatically applied. This screen allows us to zoom in or out, and also rotate with the mouse to see the various layers that make up the layout to make it easier to work with. In addition, we can separate them or see them in degree 0. For example, here is the application bar. Clicking on it opens the properties, and we see that the dashboard properties are enabled. Here is the class, the application bar control. For example, if I click on it and rotate it a bit, or even make it flat, or reset it. I click on Simas Alejandro, and information is provided about the control. It's enabled here in the control properties. The class and subclass are displayed so that I can change some aspects of the control both at the properties level and at the class level. These changes will be automatically displayed. For example, we will change this controls class to this other one that I said I'd already added. Attribute, title, brand color. And when I leave the field, the change will be automatically shown. I made the change directly on the screen, and see how it's automatically reflected in the Live Inspector, which is the same. The Live Inspector is listening to what's happening in the emulator, so the change is automatically made. Note how much time we've saved in this case. So this is what we've been saying. We can make these changes, and even change the size of the columns, and we could have done this automatically. For example, we can easily click on the control in Table 1 that has the columns and rows, and, for example, change from 10 dips to 100 dips. When we exit, we see that the change has been automatically applied, and I don't have to save this change if I don't want to. If I don't save it, it'll return to the previous size. Another interesting aspect is related to the use of images. In these images we have here, we've changed the round span property so that they take 2 rows instead of 1. Note that the image default class doesn't have any values configured for the scale type property, which means that it takes the fit value. That is to say, it'll try to fit in the space available. To change this behavior, we only need to associate it with a class that configures the corresponding scale type property. For example, this is the default one, the fit property. And we will want the property to have the fill keeping aspect ratio value so that the image is expanded while keeping its proportions. In this way, it'll be reduced properly. We need to create these classes which don't exist because only the image class will exist, causing the scale type to vary. I open GeneXus, select the theme, and open the image class. Again, these 3 classes are displayed because I've already imported the theme and made these changes. However, they won't be shown in the default theme. We need to create them. For example, this one, image keeping aspect ratio, which is a subclass of the image class. Note that I've only configured the scale type property. Here we can see the property filtering only by the class properties that have been changed. Okay, so now we will do 2 things. First, we'll set the image to expand and take 2 rows instead of 1. And there we can see the result. We will have to move this column because it has shifted. We place it correctly and delete the last column that we don't want with delete column. Now we open the Live Inspector and see that everything is in order, so we include all of it to view it better. We've said it isn't taking the entire space. It has the standard image class. So we change the class to image fill keeping aspect ratio, and we can see how everything is arranged in this way. If we look at the emulator, we confirm that everything is working as we wanted. In sum, image controls offer these options that you can see. In particular, we have fit, to fill without scaling proportionally and fill the entire screen area, and so on. This is the end of the first of the layout control themes. The next one will be multiple layouts per fit.